All right, let's now talk about another 4 interesting operations on the relations, but they are somehow related to each other. 2 of them are so-called restrictions, and the other 2 are so-called subtraction. Let's look at restriction first. And for restriction, we can subdivide into 2 operations: restriction on the domain or restriction on the range. Let's take a look. So given the same relation over here, let's talk about restriction on the domain. We can either say the domain restriction of the relation R over some set ds. So here D means we're going to take some value from the domain, okay, of the relation. Or you can say R domain restricted by ds. That's another way to say it, right? Either you can say domain restriction of R over set ds, or you can say R domain restricted by set ds. Either way, all right? Its output is going to be just another relation, but it's going to be more like a subset of R, and then with domain ds, meaning that we're going to keep in the sub-relation all the order pairs whose first elements are in ds. That's basically what's going to happen, right? Let's look at the formal definition. So this is the notation over here. You can think about the triangle over here actually tells you that it's just a triangle, and it's pointing to the domain direction, right? Remember, domain is on the left, range is on the right, and then we are saying that R is going to be domain restricted to ds over here. It's going to be all the result is going to be a set of order pair. That means the result is going to be a relation. Every order pair in the relation, in the result, dr is going to be such that dr used to be is actually for sure it should be in R in the first place, and then the first element D is actually also in ds, which is something we want to restrict to. That's basically the idea, right? Let's take a look at one example. Let's say we want to restrict to AB. Okay, let's now take a look. So let me now again use the same relation over here. Hopefully I can put all the 4 operations on the same page so you can really compare and contrast. Okay, let's now be careful over here. So let's say here we got the relation R, and since we are talking about domain into ds, so domain is on the left hand side, so it should be ds. And we are doing domain restriction, so like a triangle over here. Okay, so that's domain restriction. Okay, and now in this case ds is actually AB. Okay, so it's going to be A, B. Okay, I can move this a little bit to the right. I think that should be okay. Okay, just be more conservative on the space. Okay, all right. So how is that going to happen? Well, visually, what you can do is, since we are trying to restrict to AB, all you got to do is choose all the order pairs which involve AB as the first element. So A here, B here, A here, and also B here. Anything else? That's it, right? And then we're going to collect all such pairs. It's going to be A1, B2, A4, and also B5, right? A1, B2, A4, and also B5, right? So that's the domain restriction. So you can say this is R domain restricted by R domain restricted by AB. That's another way to say it, right? And of course, you can see in this particular resulting relation, we got A, B, A, B, which correspond to whatever we want to restrict the R into, right? That's about domain restriction. And all the other 3 are following very similar idea. It's only a matter of whether we are doing restriction or subtraction, and also are we doing towards to the range or to the domain. That's really the difference, right? Let's now take a look at the second operation. Okay, and the Ascii syntax will be, you can see this like a vertical, like a less than sign followed by a vertical bar, right? It's kind of a assemble the resemble the triangle notation over here, right? The second one is called range restriction. So we are still talking about restriction. So now what we want to do is not about the first element but the second elements. So in some way on the right hand side of the relation. Okay. So we're going to do, as you can see, the relation over here, R. And since we are talking about range, so that's why we're going to put the set to be restricted to should be on the right. And that's the opposite direction for the triangle, right? You can see that the symbol themselves are not really arbitrary. They have been chosen for a reason, okay? So the R range restricted to RS is going to be another relation over here where each member order pair, dr, is going to be such that dr is in R, in the original relation, and also the second element R is actually in the restriction set that we actually pass as input, right? That's how you interpret that. Let's see one example. Let's say we want to domain restrict, let's say we want to range restrict to 1, 2. Okay, let's see. All right, let me now just copy and paste the same relation as usual. Okay, that's number 2. What we do is, okay, we start with R, and since now we want to do range restriction, so the triangle is going to go like this. It's going to point to the right hand side, the range, and then we want to range restricted to 1, 2, right? And then the idea will be we want to choose all the order pairs that involve 1, 2 as a second element, right? 1, 2, 1, 2. That's it, right? And then we're going to collect all such pairs. So what do we have? We got A1, B2, D1, E2. A1, B2, D1, and also E2. Just always remember, whenever we do restriction or subtraction, we still have the resulting set itself being interpreted as a relation. Okay, and of course, if you do a little bit more further analysis, you can see 1, 2, 1, 2 over here. The range simply corresponds to the range that we want to range restrict to. Okay, and for this one here, if you like, I can also write it down for you just one more time. So here you can say R range restricted to 1, 2. All right, that's the first two operations. Hopefully straightforward. And then about subtraction, the other two operations, you'll be very similar. Okay, but let's now just finish them for completeness. All right, the Ascii syntax, you can see the triangle. You can see it's a vertical bar greater than, as opposed to less than, and also vertical bar. Again, it's really important to put the order right? You put the restriction set on the left-hand side of the relation if that's for domain. You put the restriction set on the right-hand side of the relation if that's for the range, right? Makes sense. The next two operations are about subtraction. Basically, we just want to remove all the order pairs which involve the restriction set either as the first element or second element, rather than keeping them. Okay, that's similar to how we do the restriction. Let's say we got the same relation here, and then first of all, let's talk about domain subtraction. Let's say we want to do domain subtraction of relation R over a certain set ds, right? Subrelation R with domain not in ds, right? That's the only difference. That's why I'm underlining that. All right, that's the definition. First of all, the symbol here you can see pretty much like a domain restriction, except that we have a minus inside the triangle. That makes sense because we're talking about subtraction. Okay, let's take a look. The result is going to be a relation, which is going to be a set of order pairs where each order pair, dr, first of all, it should be in R. However, the first element D should not be in the subtraction set that we are trying to pass as input. That's the idea. And then let's take a look. Let's say we want to subtract AB. Okay. Let me now put the third one over here. Okay. Okay, that should be good. And let's now talk about the third one. So we are still talking about domain, right? So it's going to be AB over here. But now R domain subtracted by. So this is a restriction, and put a minus over here for subtraction. Okay. Let me move the R a little bit to the left over here. And what should that be? First of all, let's find out the involved order pair, and let's see what to do with them. So here we got A, B, And that's it, right? You can see the order pair that we have chosen similar to the restriction case. But now, instead of keeping them, we want to remove them. So we're going to choose everything else. That's what we're going to do. All right. So we're going to have C3, C6, D1, E2, F3. C3, okay, let me write properly, and also C6, D1, E2, and F3. Right, that's subtraction. Now you can see that the A and B no longer is part of the domain of this particular relation over here, right? Alternatively, you can write some property over here. You can think about, I'm going to write it down here. The DS should not be there anymore. You know what? Let me save this property for later. It's actually more complicated than I thought. Beg your pardon. Okay. Anyway, so the idea is every element in this particular set is not a domain value there anymore. Simply, right? That's the idea about subtraction. Okay. All right. So this is about subtraction. So what you can think about this one is our domain subtracted to AB. Okay, maybe by is better. Okay, we got one more operation to talk about, right? We got one more. Okay. Okay, let's now go back. The final one to look at the Ascii syntax over here. So basically, you can see this part over here used to be, you can see the less than and also vertical bar. This one used to be the domain restriction, but now since we got subtraction, we simply got just another less than. So this one kind of corresponds to the minus sign inside the triangle over here, right? Just a choice of a symbol. Range subtraction, that'll be the first, the final one. Okay, so range subtraction of some relation R over a certain set, the restriction set, okay, so the subtraction set. It's going to be a sub-relation with basically the range not in RS, right? Let's now take a look. So if I say R range subtracted by RS, is going to be another relation over here where each order pair, dr, first of all, it should be in R. At the same time, R is not in the range of RS, which we want to subtract from. All right. Take a look. Take a look. One example. So what we want to do now is we actually want to subtract 1, 2 over here. Right. We want to subtract 1, 2 over here, and let's now take a look. Okay, I'm running slightly out of space. If you can just give me a few seconds, let me do a little bit of fix over here. Okay, okay, let's now select all these. And I'll just make them a little bit smaller. Oops, I clicked on the wrong thing. Beg your pardon, just give me one more time. There we go. And then I'm going to say resize. Make it smaller over here. So now we got enough space for the final operation. All right. Let's now talk about domain range subtraction. So range subtraction. So we got R. Since we talk about range, so it should be on the right hand side. And it's 1, 2. And point to the range, and then it's going to be a minus sign over here, right? That's range subtraction. Okay. It should be equal to, very quickly. So now we got basically 1, 2, right? 1, 2, 1, 2. And we're going to subtract all of them. So that means we only got what's left. C3, A4, B5, C6, and also F3. That's all we got left. C3, A4, B5, C6, F3. That's actually what's left. And we call this R range subtracted by that particular set. Range subtracted by 1, 2. Yeah, I think a more consistent use of the English would be whenever you talk about subtraction, it should be subtraction by something. Whenever you talk about restriction, it should be restriction to. So that means I better say domain restricted to this particular set. I think that'll be better, just to be more consistent. All right, so we talk about actually 4 cases, right? Let me just remind you just about the symbols. It is so important to know how to write the symbols, right? Domain restriction, range restriction, domain subtraction, and range subtraction. So these are the 4 operations that we have just demonstrated to you. Review them and make sure how to operate on them. All right, and that's the Ascii syntax again. So vertical bar and also the outside greater than itself is the range restriction, but now we're adding the middle greater than to indicates the minus over here, right? You can see this part over here. Okay. All right, I would like to stop here for this week, and then next week we're going to continue to finish off the math review. Especially we will still have to talk about the overriding operators for relations, and also we're going to move on to speaking about functions, specifically injective versus surjective versus bijective. And then after finishing the math review, we're going to go ahead and talk about our first case study of the reactive system, about a bridge controller using all the math constructs that we have reviewed. Stay tuned, and then I'll see you next week.